Alright, today we're going to look at simplifying radical expressions. This is going to be a little different than what we did in part one, where we just did simplifying radicals and that were just numbers. We are going to start by reviewing just simplifying our radicals just as a refresher, since that was already last school year. So looking at simplifying square roots, what do? We prime factor them. We look for pairs. Anything that's a pair, perfect pairs get to leave, but only one representative comes out. And anything that's not paired up has to stay inside the radical. So looking at 75, if we're breaking that down, and there's different ways to break it down. I'm going to break it down to 3 and 25 because I think about money. 3 is prime, but 25 is not, so I have to break it down more. So I'll break down to 5 and 5. So when I break it down, I have 3 times 5 times 5. I'm looking for perfect pairs. Here's a perfect pair, 2 5s. So what gets to come out? The 5 comes out. And then what has to stay in? Well, the 3. He doesn't have a partner. So that's my answer when I'm simplifying a square root. I'll try another example. Square root of 20. 20 breaks down to 2 and 10, or 4 and 5. 2 is prime, so I can keep that. 10 is not. I have to break it down further, so it's 5 and 2. So this is my prime factorization, 2 times 2 times 5. So now I'm looking for a perfect pair of 2s. So what comes out is a 2, and then what stays in is the numbers that don't have partners, so the 5. And that's our answer, 2 square roots of 5. What about with cube roots? Well, we start off the same. We're going to prime factor it. But then instead of looking for pairs, we're looking for groups of 3. Then we follow the same rule, but just pulling out groups of 3. So 24, what's it break down to? 3 and 8, 4 and 6, 2 and 12. 3 is prime, 8 is not. It breaks down to 2 and 4. And then we have to keep going. 3, 2, 2, and 2. So there's our prime factoring, 3, 2, 2, and 2. So looking for perfect triplets this time. Here we have a group of 2s. So that's what comes out. So 2's coming out. And then what stays in the cube root, remember this is a cube root, not a square root, is the 3, because he doesn't have 3 amigos. Looking at 64, what's that break down to? Most of us are probably going to think 8 and 8. And then 8's break down to 4 and 2. Almost prime, but not everything, because those 4s aren't prime, so we're going to break those down. 2, 2, bring down our 2. Make sure you don't leave anybody behind. Alright, so now we have 2, 2, 2, 2, 2, 2. Looking for 3 amigos. 3 amigos, 3 amigos. We have 2 groups, nothing left behind, so everything is coming out. But there's 2 things coming out. There's 2 groups of 2. So we're going to have a 2 come out and a 2 come out. And nothing is left inside. Nothing there. So we don't even have to write that. Then we got to clean that up. 2 times 2 is 4. So that is our answer. All right, a couple for you to do yourself. For practice, go ahead and practice doing those. Pause the video, and then when you come back, I'll walk through those. All right, so looking at these practice problems, we're going to erase this here, clear up some space. And if I'm breaking down 27, it breaks down to 9 and 3. 9 breaks down to 3 and 3. Bring that other 3 down. Looking for a pair of 3s. So what comes out is a 3. And what stays in is another 3. He doesn't have a partner. He's got to stay in there. That would be a perfect pair for a square root. Looking at square root of 72, that breaks down to 8 and 9. And you don't have to break it down the same way as me. You get the same thing at the end. Break it down different ways. And this 8, 2, and 2. Got to bring down that 2. And a 3, and a 3. Perfect pairs. A pair of 2s, a pair of 3s. We've got 2 things coming out. Taking out a 2, taking out a 3. What's staying inside? That 2 that's all by itself doesn't have a partner. Now I've got to clean it up, because on the outside I've got 2 numbers. 2 times 3, that is 6. So it's 6 square roots of 2. Number 3 is a cube root. Be very careful, look for that. Cube roots tell me, hey, I need groups of 3. And we'll break this down to 9 and 6. 9 breaks down to 3 and 3. 6 breaks down to 3 and 2. Now I'm looking for 3 amigos. There's my 3 friends. We get to leave. And what's going to stay behind in the cube root? Guys, it doesn't have friends to leave with. So 3 cube roots of 2. Another cube root. See that right there? We're breaking down 27, 9, and 3. Actually, we just did that on number 1. Now we're not doing a square root, we're doing a cube root. So we're looking for 3 amigos. There's our 3 amigos. So what comes out? Everything circled. So 1 group of 3s gets to leave, there's nothing left behind. That's my answer. So that's a review, because you learned how to do that in part 1. Now, what's different in part 2? We're going to add some variables. But actually variables are probably easier than the numbers. So what do we need to do? Step 1, same thing that we did on the front. We have to factor. We're going to factor our numbers, prime factor them, and variables under the radical by factoring the numbers into prime factors, is what I just said, and expanding the variables. So 8 is 4 and 2. 4 breaks down to 2 and 2, bring that other 2 down. X to the 4th. Well, we learned this yesterday. X to the 4th means there are 4 x's. So 1, 2, 3, 4. Y to the 2nd means there's 2 y's. 1, 2. Now I'm looking for perfect pairs. Circle pairs. That's the next step. So I'm going to circle pairs. Pair of 2's. Pair of x's. Pair of x's. Pair of y's. Circle my pairs, and anything that's partnered up gets to come out. I get to take out 2. I get to take out an x. Oh, but I have another group of x's. They get to come out too. And a group of y's. And what's left behind? Well, still have a 2 that's all by itself. He's not circled. He stays behind. Last step is to clean this up. Simplify. Remember on the front when we had to do 2 times 3 on the last, on one of the last examples that we did before the practice? Similar here, we got to clean this up. So cleaning this up, we have 2x squared. We don't need to put x times x. We need to put x, and there's 2 of them, squared. Why? Square root of 2. That's our answer. Now, cube roots. Cube roots are the same, do the same thing, except we circle triplets. We're looking for triplets, groups of 3 amigos. So looking at this example, 36, 6 and 6, and that's 2 and 3, and 2 and 3, and then p to the 4th, 1, 2, 3, 4. So this is a square root problem. So I'm looking for pairs. Important. I didn't do this. Rewrite them so that you put your numbers together, so you're not, making all these strange shapes to try to make your pairs. There we go. Now, circling pairs. Pair of 2s. Pair of 3s. Pair of p's. Pair of p's. Everything is circled, so everything's coming out. So what's coming out? A 2, a 3, a p, and another p. Last step is always to clean that up. I'm not going to leave that as 2 times 3 times p times p. Who wants to say that? I don't. I'm going to make it 6. 2 times 3 is 6. Squared. That's my answer. Example 2, 112. Well, it's even, so I know 2 goes into it. So 2 times 56, and then bring 2 down, and 56 is 8 and 7. And then bring that to 8. By now, I've done 8 so many times. I know it's 2 times 2 times 2. And then my 7. X to the thirds, 3 x's. 1, 2, 3. And y to the first, which is 1. This is square root, someone compares, pair of 2's, pair of 2's, pair of x's. So what comes out? A 2 comes out, a 2 comes out, an x comes out. Oh, that's it for coming out. What stays in? 7, an x, and the y. Now I gotta clean up the outside, because I have 2 times 2. 2 times 2 is 4, 4x on the outside, on the inside 7x. Now 2 more examples with cube roots. Remember cube roots, we can tell there's a little 3 right there. And that's reminding me, hey, you're looking for 3 amigos. If it was a 4, we'd be looking for 4. So we're going to break this down. 54 is 9 and 6. 9 is 3 and 3. 6 is 3 and 200. M squared, 2m's. N to the 9th. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, that's a lot of rate. P to the third, P. Looking for groups of 3. 3 amigos, right there. No. Oh, 3 amigos, 3 amigos, 3 amigos, 3 amigos. So what comes out? A 3, an N, another N, and a P. What stays in? A 2, an M, and an N. A little different than what we've done before. We got to do some cleaning up on the outside. That's going to be 3 N to the third P. But we also have to do some cleaning up on the inside. 2 N squared. Now someone might say, hey, there's a pair on the inside. Why didn't it come out? It didn't come out because this is a cube root, not a square root. All right, last example we're going to do together. So I need some space. Fix this one out. 250 breaks down to 25 and 10. That's the one I think of. You might think of something else. And then 25 is 5, 5, and 10 is 5 and 2. Then I'm going to get rid of that because I can't see. Go away. X to the fourth is 4x is 1. 2, 3, 4. Y to the third, 3y is 1, 2, 3. I'm running out of space. Some of these are going to go down below. 5 of them. It is a cube root. We're looking for 3 amigos, 3 amigos, 3 amigos, 3 amigos, 3 amigos. So what comes out? 5 comes out. 2 doesn't come out. He has to stay in. X comes out. But one of the X's has to stay. He doesn't have 3 amigos. Y comes out. A Z comes out. And then 2 Z's stay inside. I always put a line in my Z's because they sometimes look like G's if I'm not careful. Then I gotta do some cleaning up. The outside doesn't need cleaned up. There's nothing to put together. So it's just 5, X, Y, Z. The inside, remember, put your cube on that radical, is 2